as x approaches 2 from the left, we are here. So the tendency is, and very rightfully so, you approximated, and you should. So this should be 1.25, and you said probably 1.2. I accepted 1.23. I accepted 1.19. I accepted, yeah. So I'm going to say for now 1.2. On the other side, obviously, the tendency is here, which is at 1.25. Since these two numbers are not the same, the limit from either side does not exist. Good. Perfect. Okay. So next item on our list is back to, I'm sharing now, where is my book? I have my book open. I did not forget about that problem. Okay, so I wanted us to look at a problem from this set. Like, for example, 67 as an example. You can choose at any point in time, as you know. 67 on 113. It says graph each function. We will not, because we will graph enough later on. And then find the specified limits. When necessary, state that the limit does not exist. Okay, so in 67, we have the function f of x equals 1 minus 2x divided by x. Okay, so when we looked at limits, the first thing we did, we looked at graphs. So can I determine the limit from a graph? Yes, sometimes a little bit difficult, depending on what I have on the scale and so on and so forth. But yes, I am capable of determining limits from graphs. And if these left and right are not the same, the limit from either side does not exist. This one exists, but this one does not, because they are numbers. Okay, number two, I like to apply a different procedure to this, a numerical option. A numerical option. Okay, let's see how that works. So again, this particular function is this particular problem is asking us to find the limit of f of x. So I have to write those two. Limit of f of x as x approaches infinity, and the other limit as x approaches 0 from f of x. Okay. So what do I mean by numerical option? First of all, I'm going to put this function in the graphing calculator. Here's the function. Okay, in y equals, clear. Don't forget to put parentheses around the top. The denominator needs parentheses as well if it's more than one term, but in this case, it's fine because it's only one term. Otherwise, I would have put it in parentheses. And I want to use the numerical approach to determine this limit. So the first one is asking us to find the limit at infinity. Okay, which means, what is infinity? Okay, I'm going to start slow. I'm going to say 1,000. That's not infinity. So I see a number, negative 1.99. Okay, I continue. I'm going to say 10,000 this time. Let's see what happens. Oh, okay. It's negative 1.999, but the calculator really says it was so terribly close to negative 2. Okay, I'm going to continue. I'm going to continue with 50,000. Let's see what happens now. Oh, what about 100,000? Or whatever. I don't even know how many zeros I put in there. Okay, so it's very clear to me that the limit here is negative 2. And if you remember from the previous lesson where we had something like this, we said when x approaches infinity, the function values get closer and closer, closer and closer to 0, and that is a horizontal asymptote. Y equals negative 2, horizontal asymptote. And we checked infinity, but it's a rational function. It will be the same on both sides. Okay, now I want this. So the same thing with the graphing calculator, because I want to use the numerical approach. If I enter 0, what should the calculator say? Look at the function. Look at the function and tell me what would the calculator say if I plug in 0. Please let me know. What do you think? We discussed this situation last time. What will you say? Anyone, please? Is anyone with me? No one?
The denominator cannot equal 0.
Perfect. So if I plug in 0, what should the calculator say?
Error.
Of course, it should scream and say you lost your mind. So as you see, the function value does not exist. But this is not the question. The question is not the function value. The question is the limit of the function, the tendency, the target, not the function value. I just wanted to verify and clarify, in other words, that this does not exist. But this does not mean anything about the limit. Okay, so I'm going to go on the left-hand side with negative 0.1. Oh, okay. I'm going to get closer with negative 0.0001. Oh, then with negative 0.00000000, closer and closer, 1. Oh, what is this? This is huge negative, huge negative. Okay, let's look at the other side. So now I want 0.1 on the positive side. Oh, okay. Now I want 0.00001. Uh-oh, wow. Now I want 0.0000000. I don't even know how many zeros I have. Very, very close to 0. Oh my goodness. This is wow. So notice that I determined numerically, the limit as x approaches 0 from the left, and I determined the limit as x approaches 0 from the right, numerically, using the numerical option. Can anyone tell us what we got here and here? I can go back to the calculator. So what did we get on the left-hand side of 0, and what did we get on the right-hand side of 0?
The right, I don't know how many nines that is.
So if we don't know if it's so huge, what do we have for that?
Infinity?
Of course, absolutely. And what about the other one?
But there also be infinity, since there was a lot of numbers.
Could be negative infinity.
Perfect. Good. Now I am capable and ready to draw a conclusion here.
Does not exist.
Of course. If the two sides are not the same, especially negative infinity, infinity, there is nothing we can say. There is no such limit. What does this mean? It means that the function on the left-hand side of 0 goes to negative infinity, and on the right-hand side of 0 goes to infinity. That's what it means. So the tendency on this side is negative infinity, and the tendency on this side is positive infinity. Of course, the limit from either side does not exist. Great job. Perfect. Now let's go back to the book and take a look at, and if you'd like to choose, we can choose. I know we had at least 2 or 3 examples of piecewise defined functions. So I'd like to let you pick if you want to pick. We want to pick a piecewise defined function and graph it again. That's why I started with that, because I know this appears in this section and again in the chapter and other sections and chapters. So do we want to work on a piecewise defined function and graph it from scratch or not?
Yes.
Okay. Okay, perfect. So can I choose a one with 3, like 77?
Yes, please.
Okay, perfect. So I'm on page 2, actually 3, but that's okay. So we want 77, and that is on page 114. And after that, we're going to work on the problem that Evan asked at the beginning, because that was all I needed to explain here. So we have f of x equals x plus 1, or 2, or 3 minus x. Can anyone tell us which type of subfunctions are these? The first is x less than 0, 0 less than 1, and greater than or equal to 1. What type of functions are these? We need to be able to identify.
Piecewise function.
Correct, but this piece, and this piece, and this piece alone. Yes, correct. This is a piecewise defined function, no doubt about it. Can anyone tell us what type of functions are these pieces? Absolutely. Thank you so much. Absolutely. All of them are linear. Good, good, good. So like always, we have to start with a domain. Can anyone change these into interval notation for us quickly? Interval notation, please. Can anyone give us the interval notation for this?
Would it be negative infinity to 0?
Of course. Excellent. What about this one?
Would it be bracket
Yes.
negative infinity 0 to 1? No, 0 comma 1. Okay, so it wouldn't be negative infinity in there.
But it's not going to be a function.
Okay,
For negative infinity to 0, it's already done.
okay.
Good. Now here.
Would that be brackets? 1, comma, infinity.
Excellent. Now, from here, can you identify the domain of this function?
Okay, that's what I was trying to do, and I think I was stepping ahead. So it's parentheses negative infinity comma 0, right? Would you then put?
We're talking about this function. We're not talking about this or this or this. We're talking about this one.
It'd be infinity.
Yes. Nothing is missing. We have negative infinity to 0. We don't have 0, but we have 0 here. We have 0 to 1. We don't have 1, but we have 1 here. And we have 1 to infinity. In other words, nothing is missing. I need 0 and 1 in the table. I need the symbols, corresponding symbols. Parenthesis on the left, bracket on the right, touching. They're touching right under 0. Parenthesis on the left and bracket on the right. They're touching right under 0. I'm sorry, right under 1. I know this is an overkill, but I just want to make sure because these may not be arranged in the correct order. They are right now. So in the first branch belongs to x, the first branch belongs to x plus 1, the second piece to 2, and the third piece to 3 minus x. Since they are all linear, I need 2 points. I always look for the x and y intercepts if they exist. And for this one here, it does. At -1 is 0. At 0 is 1 inside the parenthesis, which means this is an open point. This on this side is everywhere it's 2. Inside the bracket, I have 2. 2 and 2 inside the parenthesis. I plug in 1. I have 2 inside of the bracket. But I also need that because it exists, the other x-intercept. Now I'm ready to graph. I don't need anything else because they are all linear. Because they are all linear functions, I only need 2 points. Now, I'm not lazy, but I don't need more than 2 points. So this is an full. This is open. And this is full. Good. Now, if you look at the table, we don't have the graph yet. If you look at the table and I ask you, what is the limit as x approaches 0 from the left from this function, what will you say? What will you say if I ask you the limit from f of x from x when x approaches 0 from the right? And what if I ask you what is the limit as x approaches 1 from either side from f of x? Can anyone give us this? Look at the table. We don't even have the graph. Yes.
Would that be 0?
So the function values are y. The tendency is y. So the limit of f of x as x approaches 0 from the left.
Do we -1?
The function values, I don't see any -1 here. We're looking at the function values. As x approaches 0 from the left, what are the function values? Where's the target?
1.
Of course, right here. On the other side, as x approaches 0 from the other side, what is the tendency of the function?
2.
Exactly. What will you say about the limit as x approaches 0 from f of x?
Doesn't exist.
Excellent. What will you say about the limit as x approaches 1 from either side of f of x?
2.
Exactly. Because the left has the target 2 and the right has also the same target. Excellent. Now we're ready to graph it. So what I'm illustrating here is how important this table is. Not a separate table for 3 different functions. No, this is extremely helpful. So try to understand this table. It's not difficult.
Can you please re-explain that table?
Which part? Which part?
How you got the values at the bottom, and how you link them up to being open and full, because I am confused.
So if it's a parenthesis, I'm not allowed to plug in 0. So this is the third or the fourth piecewise defined function we did. So I'm more than happy to do more, but this is just algebra. This is the calculus part, but this is just the algebra part. There is nothing here about calculus. So I'm not allowed to plug in 0, but I did. Because I plugged in 0 where I was not supposed to, and I have a parenthesis, I know that the point does not exist. So this 0, 1 has to be open. But here it's a bracket. So I'm allowed to plug in 0 here. So this will be a full point. So you have at least another 2 videos and 10 different videos from the previous semesters if you'd like to review this, if it's still not clear. So at 1, I'm not allowed to plug in 1 in the second branch. So this is an open point because I have a parenthesis. That's why I use the symbols from here, parenthesis, bracket, parenthesis, bracket. So it happens that this will not be an open point because these two values are the same. So I read from the table. So as x approaches 0 from the left, the function values approach 1. As x approaches 0 from the right, the function values approach 2. Because these two are not the same value, the limit from either side does not exist. Here, both sides, they approach 2. So that's why the limit from the left and the limit from the right exist, and they are the same with the limit from either side because it's the same number.